Kia ora koutou. This video is for Andy in our A-level class, but it's also really useful, hopefully, for Saturday Extension Calculus students. What I'm going to do in this video is go through 3 trig equations, and we're going to solve them to find particular solutions. So what I haven't written down in this is that for each of these equations, we're going to be looking for values of theta that are between 0 and 180 degrees. And I'm going to work in degrees today. So these questions are really good revision for quite a few different things in trig. They're good for compound angle identity work. They make us use special triangles. They also make us think about what trig ratio is positive in which quadrant. Right, so that's this picture here should be popping into your head. And we also need to use the graph to help find all the solutions. So I'm going to go fairly slowly in this video. If you're watching this and it's just way too slow, just put it on double speed or skip through to the bit that you need. So the first one that I'm going to look at is this one here. So 2 sine theta is equal to 3 times cosine of theta minus 60 degrees. Let's just look at what makes that a slightly harder trig equation and what would be an easier version of it. Well, it's the fact that I've got this minus 60 degrees in here. Because if I started out and I just had 2 sine theta is equal to 3 cos of theta, this would be pretty straightforward. All I'd have to do, if that's what I had, is to divide both sides by cos of theta. So I'd get 2 sine theta over cos of theta is equal to 3. And then I'd have tan of theta is equal to 3 over 2. Unfortunately, that's not what I've got. So before I can do anything, I have to deal with the fact that here I've got a theta and here I've got something else. And that's where the compound angle identities come in. And there are a few of them, but the one we need for this question is this one, that cos of a minus b is equal to cos a cos b plus sine a sine b. The next little fact that we need to use is what we call our special triangles, that if I've got special triangle that looks like this. So this angle up here is 30 degrees and this one is 60 degrees. Then I've got a triangle with lengths 1, root 3, not root 2, root 3 and 2. The other special triangle that will come up in the next question is this one here, which is the 1, 1, root 2, 1. And that's when I've got 45 degrees in here. Now, if you're not familiar with those, I've done a separate, much slower video on those, but they should be really automatic. Okay, so the first step with this question is to use that compound angle identity to expand this. And that's going to give me the following thing. So you can pause the video now and try and work through as much as you can. So 2 sine theta is equal to 3 into cos theta times cos of 60 degrees plus sine theta sine of 60 degrees. Now we're going to replace these with their exact values. So we get 2 sine theta is equal to 3 times cos theta times cos of 60 degrees is 1/2. Right, and that's from, oh, we've lost my triangle, but so cos of 60 degrees, there's 60 degrees there, that's the adjacent, and that's the hypotenuse. So it's 1/2 plus sine of theta times root 3 over 2. Now, there are a few ways to go here, but I decided to clear out the fractions. So I've times everything through by 2. That gives me 4 sine theta is equal to 3 cos theta plus 3 root 3 sine theta. So that's timesing through by 2 and expanding my brackets. Now I'm going to gather up like terms, and I get 4 minus 3 root 3 sine theta is equal to 3 cos theta. I can see that now I've got a sine theta and a cos theta, so I'm just about done. If I divide both sides through by cos theta, that gives me tan theta is equal to 3 divided by 4 minus 3 root 3. So I've done 2 things in that line, right? I've divided through by the cosine of theta, and I've divided both sides through by 4 minus 3 root 3. All right, and now we look at that and we can't do that with exact values, so let's go to our calculators. That gives me negative 0.2508. And this is the point where it's good to sketch a graph. Right, so we're asked for solutions that are between 0 and 180. And you can see that there's going to be one of them sitting about here. But when I put that into my calculator, the principal value that comes out won't be in that range. So let's have a look at it, see what we get. Well, we get negative 68.3 degrees, which makes sense. It's found me this solution back here. So to get the one that we want, we need to add on 180 degrees. And that gives me 111.7 degrees. And you can see, because you've got the graph, that that is the only solution in the domain that we want. So we want x values between 0 and 180 only. So hopefully I've convinced you that drawing a graph whenever you have a trig equation is a really, really crucial thing to do. Okay, that's all on the first question. What was the next one? Oh yeah, the next one is one where we're going to use the compound angle for tan. Now, the compound angle for tan is quite nice, but it's often easily forgotten. Yes, you will have a formula sheet in both level 3 trig and in Cambridge and in scholarship calculus, but you really should know these. You should have done so much practice with them that they're automatic. But let's just start by writing down what is the compound angle formula for tan. Well, it's tan A plus tan B over 1 minus tan A, tan B. And if I've got instead tan of A minus B, then it's pretty easy to prove that this just becomes tan A minus tan B over 1 plus tan A, tan B. So we're going to use that. Now, the one that we have to solve is this. Tan of 45 degrees plus theta is equal to tan of 45 degrees minus theta. And we can write that all out as follows. So tan of 45 degrees plus tan of theta divided by 1 minus tan 45 degrees tan theta is equal to tan of 45 degrees minus tan of theta divided by 1 plus tan of 45 degrees tan theta. Now this gets significantly easier when you remember that tan of 45 degrees is simply 1. Right, so again, using my special triangle, here's the 45-degree angle, this is the opposite, and this is the adjacent. So this whole thing simplifies to give me 1 plus tan theta over 1 minus tan theta is equal to 1 minus tan theta over 1 plus tan theta. I'm going to multiply both sides by the denominators of each side. Some of you will think of that as cross multiplying. So there we go. We get 1 plus tan theta squared is equal to 1 minus tan theta squared. And expanding both of those shows me that I get a lot of stuff that simplifies away. What have I got here? 1 minus 2 tan theta plus tan squared theta. So I can subtract 1 from both sides, and I can subtract tan squared theta from both sides. That leaves me with 0. Well, let's go the other way around. If I now add this to both sides, I get 4 tan theta is equal to 0, giving me tan theta equals 0. And again, if we sketch our graph, very bad sketch, but there you go. I know that we want theta values between 0 and 180, so theta is going to equal 0 degrees, or it's going to equal 180 degrees. Right, on to the last one. I can't remember what it was. Let's see. I'm guessing quite a few of you have probably stopped watching by now, but the last one is quite good because, oh, it's actually another tan one. It's kind of similar. So yeah, feel free if you've got the hang of these to stop watching. I've just realized that in the 3 examples I picked out, I didn't need to use this quadrant thing here. But going over that, especially for people in the Saturday sessions, what this is telling me is which trig ratios are positive in which quadrant, right? So when I'm in this first quadrant here, all of them are positive. When I'm back here, in the second quadrant, only the sine ratio is going to be positive because sine of theta is equal to my y coordinate over my r coordinate. And when I'm over here, my y coordinate is a positive number, and so is my r value, because that's always the case. Down here, tan is positive, and down here cosine is positive. All right, getting back to this last equation, cos of 60 degrees plus theta is equal to sine theta. Right, expanding out the left-hand side gives me cos of 60 degrees, cos of theta minus sine of 60 degrees, sine of theta is equal to sine theta. So very quickly doing these exact values now, because we've just done them. We've got 1/2 cos theta minus the root 3 onto sine theta is equal to sine theta. I'm going to clear out those fractions by multiplying through by 2. So cos theta minus root 3 sine theta is sine theta. I'm going to collect my like terms. Cos of theta is equal to 1 plus, I've missed a 2, haven't I? Yeah, that should be a 2 sine theta there. Right, just let me check. See, I went too fast and look what happened. Okay, yep, we've times through by the 2. So that's gone here, and it's gone here, but we have to have a 2 in here. So now what do I get? Well, cos of theta is equal to 2 plus root 3 sine theta. I'm going to divide both sides by this. That gives me 1 is equal to 2 plus root 3 tan theta. And tan theta is equal to 1 on 2 plus root 3. Now I can't do that as an exact value. That gives me 0.2679. And when I bung that in my calculator, I get out a very nice principal value straight away of 15 degrees. And I look at my graph to check that that's the only solution. But remember, we had to have theta between 0 and 180. And so you can see from the graph that there is only one solution here. Okay, that's all for now. I hope that helped. If you're in 13 MCA, let me know if you've got any other questions that you really would like done. I'm going to post worked solutions for these shortly as well. Thanks for watching.